Hi, let's continue our discussion of where we are trying to evaluate the stability of control system. And I want to take an example here. Now, let's say we have a control system whose characteristic equation is as shown on the screen. Okay, and I want to find out the condition for stability. Okay, so I'm going to use the route Hurwitz criterion, and I'm going to try to form the route array. Okay, so the first thing that you do for a route array is you write the highest value of s on the and the next highest, right? S square and s. And then what I do is, so that's my left hand side of the array. On the right hand side of the array, I fill the coefficients. So I start with a2, and then I write a1 here, and then I write a0 here. And I have basically reached the end. I have put all the coefficients on this on in the array. So there is a blank value here. So this blank value is going to be just 0. Okay. So now let's just extend this array, and I want to find out the value that is going to be the next one. What's the coefficient going to be here? So the coefficient just goes down. So it was s square, s to the power 1, and now it's going to be s to the power 0. And what I want to do is I want to find out the value at this position. So to find out the value at this position, what I do is I take the first two, okay, the elements in the first column of the row above this element, right? So those are going to be these two elements. And then I'm going to take the uh, elements in the column immediately after the column of interest. So this is my column of interest. So these two elements. And what is my value here going to be? It's going to be minus 1 over a1, and the determinant is a2, a1, a0, and 0. And if you evaluate this, you will get minus 1 over a1, a2 times 0 minus a1 times a naught, and that's going to be equal to a0. Okay, so the value that goes here is going to be a0. Now, what is the condition for stability once I have made the route array? The condition for stability is that all the elements in the first column, in this column, which is a2, a1, and a0, have the same sign. Okay, so if a2, a1, and a0 have the same sign, then we know that the system is stable. So that's the condition for stability. And remember, in a few videos back, we had looked that for second order system, the necessary and sufficient condition for a second order system to be stable was that the coefficients of the characteristic equation would be of the same sign, and that's the same condition that we have got here.